Hi everyone, today we're going to be talking about the relationships that exist with specific transformations. So you're going to want this chart filled out in your notes, and we're going to input everything into it, but you're going to want to start by pausing and just copying this down. So now that you've had this written down, I hope you paused it. Really quick, I want to just go over each term. So on the left side, the relationships, size means that it stays the same size or it doesn't stay the same size. So the distance from A to B to C, if it were a triangle, is all the same or it's not. Orientation is the order of the letters. So if you want to put that underneath orientation so you remember what that means, it's the order of the letters. Invariant points are points that don't change. So again, if you want to write that in, invariant means doesn't change. And parallelism means that the image and pre-image are parallel to one another. And just to be clear, we're talking about each side separately in this case, not the shapes themselves, but each side of the shape. So we're going to go ahead and talk about rotations first. So here is a picture of a rotation. So the first question is size. Does size stay the same? Well, if you rotate the pre-image and put it onto the image, they 100% are going to be the same size. That would stay the same, right? If you turn your coffee cup or you turn your mask or whatever, right? If we turn something, it doesn't change the size of it. So size stays the same. Orientation is the order of the letters, and here's how you figure that out. You start with a letter like A. So if you look over at your pre-image, you start at A, and then go to the left or go to the right. Just make sure you stay consistent. So if I go to the left, I read A, B, C. So now I'm going to go over to my image, A prime, B prime, C prime. And again, because I started counting at A, I'm going to start counting at A again. So A prime, if I go to the left, so counterclockwise, I have A prime, B prime, C prime. So I'm counting in that same order. So that means that the orientation stays the same. The orientation did not change. The next one is invariant points. So that means points that don't change. In a rotation, the only point that doesn't change is your center of rotation. So in this case, point P. Sometimes it's a point on the shape, but that would be the point that doesn't change. Okay. Now that I have my stylus out, I just want to reiterate. So like A, B, C, A prime, B prime, C prime. That's what I mean by that. Or if I started at B, it would have been B, C, A. If I started B prime, C prime, A prime. It's the same order. Okay. And then finally, parallelism. And again, I'm going to draw for that one because it's going to be the easiest way to see it. Let's just focus on one side. So AB. So AB, if I extend it, is this side of the pre-image. A prime, B prime, if I extend, is that side. Well, they sure are not parallel because they're crossing right there. So they are not parallel. So just review that. A rotation is going to keep the same size. The orientation will stay the same. Points that don't change is going to be the center of rotation, and it does not preserve parallelism. Moving on to reflection. So here's our picture of reflection. Does the size stay the same? Yes, it sure does. Those are congruent to one another, those two pink triangles. Orientation. So again, let's try this. So if I start at A and I go to the right, so A, B, C is the order I went in. Okay, I'm going to start at A and I'm going to go in that same circular direction. A prime, C prime, B prime. Notice I went in a different order. On the top I went A, B, C. On the bottom I went A prime, C prime, B prime. So this does not have the same orientation. That's actually a really, really big fact about reflections, is that they do not preserve orientation. For invariant points, well, I want you to think if I had a point right here, let's call this point D. If I reflect that point over the x-axis, it's not going anywhere because it's already on the x-axis. It's on that line of reflection. So any point on the line of reflection will remain invariant, meaning doesn't change. And the last one is parallelism. So again, if I extend AC and I extend its image, A prime, C prime, notice that they touch. So this does not preserve parallelism. So again, to recap, a reflection stays the same for size. The orientation changes. That's a big thing to know about reflections. The invariant points are the points on the line of reflection. And is there parallelism? No, there is not. It is not preserved. We're going to go ahead and move on to translations now. So a translation, does the size stay the same? Well, those are the exact same size because AB is a length of 2, right? We could count all of our lengths. They're the same size. So size stays the same. Does orientation stay the same? Well, let me go to A, B, C, D. If I go in that order, A prime, B prime, C prime, D prime. So yes, the orientation does stay the same. I said the letters in the same order each time. Invariant points. So with a translation, when you slide it, everything moves, right? If I move to the right, everything moves to the right. If I move down, everything moves down. So with a translation, there are no invariant points. Everything moves no matter what. And then parallelism. So let's look here. If I extend A prime, B prime, and extend AB, they don't cross. Let's do B prime, C prime. If I extend B prime, C prime, and BC, they also don't cross. They are parallel. So a translation does preserve parallelism. So again, to recap, the size stayed the same. Oops, looks like I did all of them here. Ooh, you're getting the whole thing. Translation, the orientation stays the same. There were no invariant points. And yes, parallelism was preserved. So same, none, yes, and you got all the answers for dilation, but we're going to talk about it as well. So size clearly does not stay the same with dilation, so size is definitely going to be different. Orientation, again, I start at A prime, C prime, B prime, go the same direction, A, C, B. I said the letters in the same order, so the orientation did stay the same. Invariant points, that's going to be the center of dilation. So in this case, there isn't a point on the center of dilation, but let's say I drew this other triangle. Let's call this DEF. If my center of dilation was point D and I dilated it by 2, I would extend everything twice as far. Notice D prime would be right where D is because that was the center of dilation. So that's an invariant point, a center of dilation. And then for parallelism, well, let's try it. Here's AB. Here's A prime, B prime. They're parallel. Let's check it with AC and A prime, C prime. Also parallel. So yes, it does preserve parallelism. So this was the slide that I flipped them. I thought I did it for the other one. But either way, so there's your dilation. Different size, same orientation. The center of dilation does not change, and you do have parallelism between the two, the image and the preimage. So that's it for this video. We are going to be using this when we come back from break because this is where we are going to move into how to identify transformations. I hope you have a great day. Make sure to send me your notes, and I will talk to you later.